My name is Jose Brandao. I am the Assistant Professor and Extension Food Safety Specialist. And today I'm going to be speaking a little bit about harmful algae blooms and it-related food safety. So harmful algae blooms is something that we used to correlate more with the oceans, with the red tides that we used to see all these fish which wash up to the shore dead, and those were caused by dinoflagellates. However, now we are seeing more and more in fresh water these harmful algae blooms. And these are caused by cyanobacteria. These are prokaryotic bacteria that are able to photosynthesize and they produce harmful toxins. We can also have algae blooms that grow uh, exponentially that doesn't produce toxins and they can reduce the content of oxygen in the water and kill fish. However, those are not toxic to humans. In this presentation, I'm going to be focusing more in the harmful algae blooms, the ones that do produce the toxins. So what is the cause of these harmful algae blooms? We have different stuff going on. We are going to have two principal. One is going to be nitrogen and phosphorus. And the phosphorus is the key one. The kind of bacteria, they are capable of fixate atmospheric nitrogen. So the limiting element will be the phosphorus. And they can get that one from several sources. Agricultural runoff, and basically we are speaking about fertilizer, urban runoff. We can get that from wildlife. Uh, Also, we are going to have the water temperature. So extreme weather events are going to have a high impact on the frequency of harmful algae blooms. And in the last decade, we have seen more and more of these events happening inland. Pre-1972, those were isolated events. Now is a common occurrence every year, especially having longer summers, falls, with temperatures that increase these conditions. Because these algae use sunlight, they will prefer a high light coverage. However, this is the ideal conditions for um, an algae bloom. Doesn't mean that when we don't have all these ideal conditions, they cannot occur. They can occur in less concentration, in less amount, in very specific parts of a reservoir, lake, a river. eh, However, based on the ideal to poor condition, we can have more or less. So, these kind of bacteria are not consumed by the zooplankton, the filter feeders, and when they are in high concentrations, they can kill the wildlife, including the fish, and they coincide with the recreational periods. And one of the concern is that these kind of bacteria are going to release toxins. They are going to release these toxins not only when they are living, they are going to release it when they die. And they are going to release it in high concentration when they died. And also, they are going to release phosphorus. That means that when they die, they promote the growth of harmful algae bloom. And when we have these kind of toxins in the water, they are persistent. They are hard to be degraded. So it happens as a natural process, but it takes time. And is even though we are speaking about phosphorus, we are speaking about nitrogen, it can occur even if it's not a nutrient-rich water. So what can we do? We can apply algicide, but this has to be done in a very controlled manner because, as I say, when these algae, this kind of bacteria dies, they are going to release the phosphorus and they are going to promote more blooms. Also, if we use algicide, we are going to be killing the beneficial algae, the one that is not toxic, that are not kind of bacteria, and they are not going to have competition anymore. So a concept that I'm going to be speaking is the amount of the biody, the source oxygen, the biological oxygen demand is important because we want oxygen in the water so the wildlife, the fish can survive. When we don't have that oxygen because of excessive organic matter, we are going to see our wildlife being affected. So, what is the impact of these harmful algae blooms? When we go to human health, we are going to see that these algae blooms are have a mortality rate that is extremely rare. So most of the time, humans are not going to die because of these issues. However, that doesn't mean that our quality of life cannot be affected. Harmful algae blooms can affect liver, kidney, they can promote cancers. So the quality of life of somebody that is infected by these toxins can be a long-term chronic consequences. Pet health is a little bit different. When the pet get into contact with harmful algae bloom, and that means drinking, swimming, eating plants that are close to this water, they are going to get intoxicated. And when you have a pet that needs to go to the vet, in 2023, those had a 92% mortality rate. So for everyone that loves their pet, this should be concerning. Also, a number that is more difficult to estimate is the wildlife loss. And that's very similar to pet health. However, those numbers, there's very smart people that are working to have more and more precise estimates. All of these translate to economic losses. We are going to lose because of the cost of this illness. We are going to have loss of tourism, economic. We are going to have close of fisheries. Uh, the estimate harmful algae blooms in the United States go from 20 to 100 million. And this extreme number at the end is because of a recent event where there was an estimated loss of $94 million for the closure of the fisheries. So as I say, the different symptoms that we are going to have are basically gastrointestinal system, neurological, flu-like system, respiratory, skin, mucus, etc. However, if you go with these symptoms to a doctor, there's no test that they can do to say this is because of cyanotoxins. Therefore, the doctor is going to rely on the information that you provide them to be able to make this uh, determination. So it's very important to share that you were swimming, what were you doing before getting these symptoms. There is at the best of my knowledge, any kind of antidote or treatment for these kind of toxins. And the only the at this moment we are treating those by symptoms only. These are some statistics from 2022. We have 372 harmful algal blooms events. We can see how many of those were inland, and we can see Utah. We have 39 events and 54 human illness for this year. And that's a little bit high compared to the amount of illness there were in the rest of the country. Now, something that I found that is very important to have in mind is that yes, most of the time harmful algal blooms, they are going to look like paint, they are going to be streaking in the water. However, they can occur in clear waters. That means that the water looks pristine and they are there. This usually happens when we are dealing with species that are at the bottom. Therefore, we should always be looking for the regulatory guidance to know if the reservoir, the lake, or the place where we are getting our water or where we are going to be doing our recreation is in the proper state to be doing those activities. I believe that we should be proactive in that sense. And these are more of those statistics for that year. Uh, these include also the events in the ocean. So we are seeing also diatoms and dinoflagellates. Those are what we say the red tide. However, we have in great amount the cyanobacteria, especially the microcystin. That is the most common toxins associated with cyanobacteria. Now, let's start speaking a little bit about the impact on crop safety. At this moment, there has not been an outbreak related to a harmful algal bloom, at least not at my acknowledgement, especially not in the United States. However, these events are becoming more and more prevalent. We are having more and more extreme weather events, longer summers that can promote the ideal conditions for harmful algal blooms. Therefore, we need research that start looking at what can we do. One very interesting research is that when we irrigated a winter-cool olivera irrigated lettuce, and after 15 days of irrigation, that lettuce bioaccumulate 143 micrograms per kilograms of microcystin in their tissue. Washing was not able to remove these toxins. And that, for me, is the concerning part. That means that we need to start thinking about what can we do to make this safe. The biggest correlation from these studies is that the higher toxin concentration in the irrigation water, the greater accumulation in the crops. Therefore, we should be using water sources that doesn't have harmful algal blooms, or we should be start thinking about remedial measures. Here I have some facts. The EPA recreational water guidelines. We have also the water rule. Maybe we should start thinking about risk assessment of these kind of water sources. There are several kind of water sampling and testing methods for harmful algae blooms, and they are becoming more prevalent, more different way to see those. Not necessarily we need to test for the toxin, we can test for the kind of bacteria, then we can get confirmation that they are or not present. So there are several tools at our disposition to be able to monitor the water. Also, we can leverage satellite imaging to know where blooms are formating and the movement that they are having. So what are some of those remedial treatments that we can use? We can use activated carbon. That one is effective to remove the microcysteines and the cyclodose persins. We can also do membrane filtrations. However, this one can get really expensive. We also can use biofiltration. This is an image of an example of a biofilter. Basically, we use bacteria to degrade these different kind of toxins, or we can do algae bioremediation. That's basically introduce those non-toxic algae species to compete with the harmful cyanobacteria. We can also use chemical treatments, chlorination. However, these only work well for low concentration of toxins because the chlorine uh, combined with this toxin can produce harmful byproducts, and we should be concerned of that. Ozonation works well also, breaking them into harmless compound, and potassium percarbonate. Now we have some novel treatments being studied. Hydrogen peroxide has proved very successful to treat these kind of toxins. This was done on tanks. However, we have killing the kind of bacteria and also removing the toxin. But the concentrations that show the best results would be toxic. We should be thinking at concentration less than 10 milligrams per liter. We also have ultrasound. The ultrasound shockwave disrupt the cyanobacteria and introduce the formation of oxygen reactive species, which can degrade the cyanotoxins. The proposed treatment, 20 kilohertz, this one would be effective for remove 87.6% of cyanobacteria. And why this one and not the most effective at 90 hertz? Because this one will not be energy efficient. However, ultrasound is at large scale what we'll need for irrigation tank that can get expensive. Now, a little bit about livestock. They can get sick from harmful algae blooms and potentially they can die. And something to note is that livestock prefer cyanobacteria water. So we need to be proactive into trying to prevent access. And in this case, the bioaccumulation in their tissue is minimal. The impact on dairy products is that it's suggested by the research that there is minimal transfer from these kind of toxins into the milk. And however, there is further research needed on the long-term or chronic exposure. Uh, these are our Utah Department of Environmental Quality. They do a great job monitoring the different reservoirs. And here you can get more information. And that's what I have for the presentation. And now I'm going to be answering questions if we have any question on the Q&A.
Great. Thank you, Jose. We don't have any questions right now in the queue. You'll notice the evaluation that should have popped up. Please, you'll see one of those at the end of each presentation. Please take a moment and provide your feedback. And we've got a few minutes here
Brandao,
before
I have a couple questions for Jose, maybe while other
Please.
folks are working on populating some, if that's okay. I
Yes,
apologize.
please.
I can't enter him in as a panelist in the Q&A function, so I'm just going to pop in for a second. Jose, if you have just a backyard gardener who is using secondary irrigation water that is coming from from some sort of a reservoir or water source that has been cited to be impacted by these toxic algal blooms or HABs. What kind of advice would you maybe give to that gardener in terms of consumption of their backyard produce? Do you have any tips for them?
I will ask them to monitor those levels if there is an advisory on that water, especially a danger advisory. I will request them to stop using that water. However, I I think that the likelihood of they needed to stop using that water, it has not been proved yet. But they should be careful using that, especially if they know that it's in contact with harmful algal blooms. It is it will be better to try to use an alternative water source. I know that not always that is a choice, but this is the best resource that they have. In seafood safety, that's what they always recommend. Check with your local authority, see what is the current recommendation, and stay away from that. There is there's something that I am missing here is on seafood. We do have bioaccumulation of harmful algae blooms. And when we have this advisory in place, we should get away from recreational fishing. Fish, very different than livestock, can bioaccumulate the carnotoxins. Therefore, if we are doing recreational fishing, we need to be careful. Those are different than the livestock. Those are different than the wild animals. And what will be recommended in fish will be to just eat the tissue, remove the skin, remove any organ, and just eat the muscle, because there is less concentration of kynotoxin in those parts of the fish.
Can I ask one quick follow-up question too? You were mentioning that with the HABs, that even after they are no longer living, that they still carry the toxin. If a grower, for example, or a gardener was growing something like a pepper plant, and maybe they were doing some sprinkler irrigation, so some of that water was landing on the surface of that pepper. Even if the advisory had passed and it had been some time since the advisory was active, would it be safe, or would there be caution in consuming that fruit or vegetable later in the season based on that prior exposure?
That's a good question and not have a direct answer right now. I would like to have a, a better answer. However, if the advisory is passed and they are using the water that is not on their advisory, they should be fine. Now, if they maybe harvested that water and they have it in reservoir tanks, that will be a different answer. They probably should just change that water.
We have a couple questions here, Jose, in the Q&A. One you've maybe indirectly answered, but it is, have studies been done for crops and irrigation? So kind of getting to what Katie's question was, but is there research related to that, to the...
Yes, the biggest amount of research has been done to see if the toxin bioaccumulate on the produce. And this is a small summary of those research and how much they bioaccumulate in the in the edible parts. And that is the biggest finding, high toxin concentration, greater accumulation. However, I will answer in the chat with some review papers that have a better summary of this research.
There's one other question here, and then we'll, if there's any further questions, you can type them in the Q&A, and Jose will be on to answer those through the Q&A, just typing the answers. But this last one is wondering if you could address using solar distillation as a means of water treatment, if you think that is kind of feasible.
Cyanobacteria, they do use the solar radiation to do photosynthesis. However, maybe the question is more related to UVC, UV light that can be used to disrupt cyanobacteria, and they may be the opportunity to see if UVC or maybe UVA, if we have a little bit more of time in reservoir tanks, can be used to try to reduce those kind of bacteria in irrigation water. However, that needs to be proved by research.
Thank you.